In this video, we'll be solving systems of linear equations by using the addition method. Let's do some examples. So for the first system of equations, notice how the first equation has a positive y and the second equation has a negative y. This means if we add the two equations together, we'll be able to cancel out the y's and only have the variable x. So if we add the two equations, we get x plus x, which is 2x, y plus negative y, which is equal to 0, and 7 plus 5, which is equal to 12. At this point, we can divide 2 on both sides to get x is equal to 6. Now that we know that x is equal to 6, we can substitute it into any of the two equations we started with to solve for y. Let's use the equation x plus y is equal to 7. Now substituting 6, we get 6 plus y is equal to 7. If we subtract both sides by 6, we get y is equal to 1. Now if we were to graph the equations, we will see that the point of intersection happens at 6, 1, exactly what we solved for. Let's do another example. So for the second system of equations, if we just add these two equations, no variables will cross out. We'll just get another equation with two variables. However, if we multiply the first equation by negative 3 on both sides, that will give us negative 3x plus 6y is equal to negative 33. This is an equivalent equation to the original. Now, if we add these two equations, we get negative 3x plus 3x, which cancels out, 6y plus negative y, which is 5y, and negative 33 plus 13, which is negative 20. Now, if we divide by 5 on both sides, we get y is equal to negative 4. Now, if we substitute negative 4 into the equation 3x minus y is equal to 13, we get 3 times x minus negative 4 is equal to 13. Simplifying, we get 3x plus 4 is equal to 13. Subtracting negative 4 on both sides gives us 3x is equal to 9. We can then divide by 3 to get x is equal to 3. Now, if we graph the equations, we'll see that the point of intersection happens at 3, negative 4. Again, exactly what we solved for. Let's do one more example. So if we look at the second equation, we can see that this equation is not written in standard form. If we add 4x on both sides, we get 4x plus 2y is equal to 0. Now before we add the two equations, we can multiply the first equation by negative 2 to cancel out the x. So distributing the 2, we get negative 4x minus 2y is equal to negative 14. Now adding the two equations, we get negative 4x plus 4x, which cancels out, negative 2y plus 2y, which also cancels out. So we have 0 is equal to negative 14. Now this is a false statement, which indicates that the system has no solution and is inconsistent. If we graph the two equations, we will see that the two lines are in parallel and will not intersect.